Assalamualaikum warahmatullahi wabarakatuh. In this video, our group would like to share our experiment, which is called the eddy current tube experiment. In our experiment, we are focusing on two types of law, which are Lenz's law and also Faraday's law. Before we start towards the experiment, let us explain the theory of both of the laws. Let us start with Lenz's law, the main focus in our experiment. Lenz's law of electromagnetic induction states that the direction of the current induced in a conductor by a changing magnetic field, as stated in Faraday's law, is such that the magnetic field created by the induced current opposes the initial changing magnetic field which produced it. The direction of this current flow is given by Fleming's right-hand rule. So what is Faraday's law? Faraday's law states that a current will be induced in a conductor which is exposed to a changing magnetic field. In other words, when a conductor, which is in our case the copper tube, is exposed to a changing magnetic field which is caused by the neodymium magnets, it will induce a current inside the copper tube. The current is called eddy current. In this experiment, we are only using two materials, which are a non-magnetic copper tube and also magnets, which in this case we are using neodymium magnets, 4 of them. As we can see here, the copper tube is non-magnetic. The magnets are not attracted to it. It straight falls to the ground. First, we use a AA battery and it straight falls to the ground in just 1 second. And now we are using the magnets. So we are going to let go of the magnets when the second hand strikes 12. As we can see, the magnet took 5 seconds before it reaches the ground. And as we can see here now, this is the top view of the same experiment. And as we can see, the physical friction does not apply in this experiment because the magnet does not even touch the copper tube at all. So the resistance that caused the magnets slowing down, reaching the ground, it is called the phenomenon caused by the Lenz's law that is being stated in the theory before. As illustrated in this diagram, we can see that there is a change in the magnetic field as the magnets descends the copper tube. Therefore, induces eddy currents, which also produces a magnetic field that is opposing the direction of the magnets, which is going downwards, therefore creating a resistance that pulls the magnets up. But due to the presence of the gravity pulls back the magnet downwards, as it makes the resistance produced by the magnetic field become smaller until a constant speed achieved. Therefore, the magnet will continue to go downwards in a constant speed in 5 seconds.
Through the observation, we can say that when the magnet goes through the copper tube, it creates a magnetic field around it. And as it descends towards the ground, there is a change in the magnetic field. Therefore, eddy currents are induced. The eddy current produces a magnetic field with an opposing direction to the magnets that are going down. This creates a resistance that slows down the movement of the magnets. Therefore, the magnets took the whole 5 seconds to the ground compared to the AA batteries that took only 1 second to go from the top to the bottom of the copper pipe. This experiment proves that we obey the Lenz's law, the Faraday's law, thus our objective is achieved and the experiment is a success.
Before we end our video, we hope that our experiment can give a general review on what is Lenz's law and Faraday's law is all about. We also hope that our video is beneficial and can inspire people to love science more. And we think that's all from us. Thank you for watching our video.